As per the last class discussion of the torque of a force about a point which is defined as an axial vector and its magnitude can be given by the formula r f sin theta, and the direction is given by r cross f vector. Combiningly, both magnitude and direction can be given by this familiar formula r cross f. Torque about a point O of a force can be given as r cross f. If you draw the force vector here, bring the tails of the force and displace position vector to a point. This angle is theta. The magnitude of the torque can be given by the magnitude of r cross f vector. A cross b is equal to ab sin theta. Similarly, r cross f is equal to rf sin theta. So, this is the magnitude of the torque. The direction part of the torque is given by the concept of A cross B formula or R cross F. R cross F, R cross F, the sense of the angle is clockwise, therefore, the torque will be clockwise. R cross F direction or clockwise direction or in or minus KAB direction. If you take xy axis as shown in the diagram, this formula of the torque gives us magnitude. Here I can write by regrouping f into r sin theta, or this can also be written as f sin theta into r. Therefore, if you take this part r sin theta, this is theta, this is theta. R sin theta, you drop a perpendicular from the point P onto the line of or onto the force vector. Let the length of the perpendicular be P from here to here, and P is equal to r sin theta. So, instead of r sin theta, we can write P. The force into the perpendicular distance from the point of application of the force to this direction or onto this line, or you can call reference point. This is the line along which you are applying the force, called line of action. This P can also be called the perpendicular distance from the reference point onto the line of action. You drop a perpendicular from the reference point onto the line of action, that is the r sin theta. Here P is the perpendicular distance from the reference point P to the line of action of the force F. If you take f sin theta, this gives us which component? If this is theta, we can write this is theta. Therefore, the projection of the force along the r vector is f cos theta, and the projection of the force normal to the r vector is f sin theta. We can call it f parallel, we can call it f perpendicular. So, this perpendicular component of the force onto the r vector. So, the torque of the force about the reference point can be written as the product of the force magnitude and the perpendicular drawn from the reference point onto the line of action, can also be written as the position vector of the point of application of the force with respect to the reference point into the component of the force perpendicular to the position vector. In both the ways you can write the torque. Okay. In the direction you can get by using the A cross B idea of vector product. R cross F, this is directed in the direction of R cross F. This is R, this is F, R cross F. You start the angle from R and end at F, so it is moving in a clockwise sense. The direction of the torque therefore is clockwise. Well, this is the expression for magnitude. Rf sin theta can also be written as F into P, can also be written as R into F perpendicular. Since the force is multiplied with a distance, torque can also be called moment of force. It's called torque can also be called moment of force. Anything multiplied by distance, anything multiplied with a distance can be called the moment of that thing. When you multiply the mass with the distance, is the moment of mass. When you multiply the charge with distance, is the moment of charge. Similarly, when you multiply the distance with the force, this is the moment of force. So, torque can also be called moment of force. Next, we will deduce the expression for the torque of a force acting at a point having the coordinates x, y, z with respect to the origin or with respect to the reference point, whose coordinates can be x dash, y dash, z dash, like that. Or you can call it x1, y1, z1, it is x2, y2, z2. This force has three components. In this way, by determinant method, we can get three components of the torque, and each component can be called the projection or the component of the torque along three mutually perpendicular axes.